Everybody say, what's up, people? Guess what? I'm back. Come on. Let's get jiggy with it. Shake your tail feather. All right. Today we're going to talk about one topic we've already discussed, which would be independent probability. But now we're going to also compare and contrast that with dependent probability. So we're going to talk about independent versus dependent. Are you ready? All right. So if you know that song's playing in the background, you can send it to me later. All right. I'll give you another little clip of it here at the end. All right. So the paper you're going to be working on today, your questions, are going to be looking like this. Okay. So, if you want to have the PDF or whatever pulled up, this is what we're going to be talking about here in just a minute. But I just want to talk to you a little bit about the difference between these two words, independent and dependent. All right, independent. Now, eventually your parents are going to want you to be independent and get out of the house and go buy your own house or live in your own apartment or whatever. So independent means they happen separately, okay? Separately. And so you're going to have something that happens maybe over here on this spinner and something that happens over here on this dice or whatever number cube, and those events are going to happen separately, and they don't really have anything to do with each other, okay? But you're still going to have to multiply those together. So you're going to multiply the two probabilities together. All right, and so I'm just going to, since we're talking about independent first here, okay, I'm just going to go ahead and come up here and talk to you about the fact that these in the top part up here, most of these are the independent part. So let's just go ahead and do one of them just while we're talking about it, okay? So what, of course, you'd spin on this spinner has absolutely nothing to do with what you're going to spin on this spinner, okay? So these are independent events. So let's do this one right here. We'll do letter O. So, we'll hit this first one right here. So what is the probability of not red? So if you come over here and look on this spinner, the first one, hopefully you can see that all right. Let's get it straightened up. There are 2 sections that are red, but there are 3 sections out of the 5 that are not red. So right here I'm going to write 3/5, okay? And I got that part. Now, that spinner, again, is independent of this spinner because these don't have anything to do with each other. So on the second spin, you'd come over here to this spinner and say, what's the probability of spinning the X? Okay, and you can see there's 1 section out of 3 that's X. So that would be times 1/3. So again, we have to multiply those 2 independent probabilities together. Excuse me. All right. So you can cross-reduce these if you want to and say 3 goes into 3 one time, 3 goes into 3 one time. So you could scratch those out and cross that out and reduce it that way. Okay, so I'm just going to do that. 3 goes into 3 once, 3 goes into 3 once, and then 1 times 1 is 1, 5 times 1 is 5. So you can see that theoretical probability of spinning those spinners, getting a not red and an X, is 1/5. Okay, then these answers in the top section up here, okay, go with this row of answers in the middle. So you can see there's a 1/5 right there. So I'm going to come right there to that 1/5, and I'm going to put my letter O. All right. Now, I'm also coming down here and do one of these. So let's do W right here. We'll do not white and odd. All right. So you can see there is a spinner here. Okay, and it is independent. Okay, your results you're going to get on here are independent of what you roll on the number cube. Okay, so just remember over here, even though you can't see all the numbers, you guys know that this has a 1, 2, 3, 4, 5, and 6 on it. Okay, even though you can't see the other 3 sides, it is a 6-sided die or a 6-sided number cube, and it's got 1 through 6 on it. Okay, so if we come here to this one, it says what's the probability of not white? So if we look here, not white would be 1, 2, 3 out of the 4. I got that, so that would be 3/4. That's my first probability. Now the other independent probability here would be getting an odd number here. So the odd numbers are 1, 3, and 5. So 3 out of the 6 of them are odd. And I'm going to go ahead and take that 3/6 and simplify that down. Hopefully you know that 3/6 is a half. Okay, so all I did was take the 3/6 for odd and go ahead and simplify it down to a half. So 3 times 1, of course, is 3. 4 times 2 is 8. So the theoretical probability of spinning a not white and then rolling an odd number is 3 out of 8. That is the theoretical probability. So do you see a 3/8 down here somewhere? Let's see. Oh, there it is over there. Okay. So for 3/8 right there, we would put letter W for that. All right. Now, on the word problems, again, remember, you're going to multiply 2 probabilities together. Okay? Going to multiply 2 probabilities together. How many seconds are in a minute? 60 seconds. So okay, on this one, you'd have 20 over 60. On this one, you'd have 35 over 60. So then, of course, you could simplify those and make it a little easier on yourself. And I would do that. Make sure you simplify them before you work them out and multiply them together. Okay? All right. Now, let's talk a little bit about dependent events. Okay? So you can see independent events happen separately. Okay? So what happens on one item doesn't necessarily have any effect on the other item. Dependent is what you currently are now. Okay? You are considered a dependent. All right, and that means you're counting on somebody. You're counting on your mom and dad to take care of you, or your grandparents, or a foster parent, whoever. Okay, somebody is taking care of you. You are dependent. Maybe brother, sister, aunt, uncle, whoever. Okay, so dependent means one event is affected by the other. So let's just say this. Let's say that, my wife and I both work, and, we're both making payments. We're paying on the house, we're paying on the cars, we're paying for the college education. Well, let's say something happened to me and I wasn't able to come to work anymore, okay? And that would mean all of the bills and everything would be on my wife, okay? That event, me not being able to come to work, is going to affect a lot of other people, my wife and my daughters, okay? So one event can affect the other one. That's what being a dependent means, okay? So in this situation, all right, this is on the bottom half of your assignment today, we've got the word aardvark down here, okay? So here are the key words. It says if you pick a card, do not replace it, then pick a second card. And this one, it says if you pick 2 marbles without replacing the first. So this is a little bit different than what we're used to, okay? So let's talk about those words. Do not replace. Okay, so I'll give you a little work here, show you how this one works, and hopefully after a couple of these examples you'll be good to go. All right, so we've got the letters here in the word aardvark. Let's do the first 2 together here, so that'll give you a little helpful hint. So we're going to do the probability of V, then we're going to pretend like we picked the V, and then we're going to pick the K, okay? So this, again, this is dependent events. So to start out with, all the letters are in the bag, okay? You can see all the letters in the word aardvark. I'll cover the other stuff up. So what's the probability you pull the letter V out of aardvark? Well, there's 1 V out of 8 possible cards, right? So theoretically, the V is 1/8. Okay? Now, let's pretend we do pull out the V, so I'm going to cover it up. So let's pretend we reached in there and we picked out the V, and the V's not in there anymore. So I'm just going to cover it up with my finger right there. Okay? You can still see the rest of them. All right? So we are not putting the we picked the V out of the bag, but we're not putting the V back in right now. Okay? So what's the probability you pick a K? So if you look down here, out of the letters that are left in the bag, you got 1 K left out of 7. Okay? So that would be 1/8 times 1/7. Of course, 1 times 1 is 1, and 8 times 7 is 56. And if you come down to the bottom row of answers down here, you'll see that a 1/56 is right here, and you'd put your letter O in there for that one. All right, so once you're finished with the question, all the letters go back in the pot again, so you can see all the letters back in aardvark. So every time you start the question over, all 8 letters go back in, and you use them again, okay? So now let's come over to question letter T here. All right, so it says what's the probability of A, and then the probability of R. So if we do A's, we got 1, 2, 3 A's out of 8. Okay, so we got A is 3 out of 8. Okay, so you can pick any one of those A's and just cover one of them up. All right, I'm just going to cover up that one. So I pretended like I reached in the bag and I pulled out one of the A's. Now what's the probability of the letter R? Well, I've got 2 R's left out of 1, 2, 3, 4, 5, 6, 7. All right, so I got 2 out of 7. And you can see that like this first one, we started out with 8 cards, then we went to 7. Here in this one, we went back to starting out with all 8 cards, and we took one out, and then we're back to 7. So it's going to be like that for every problem for this one, okay? 8 and then 7. Then on the next question, you go back to all 8, and then you take one out, and it's down to 7, okay? So let's multiply these out here. I can cross-reduce these, okay? 2 and 8. 2 goes into 2 one time. And 2 goes into 8 4 times. So that will simplify it that way by doing a little cross-reducing. 3 times 1, of course, is 3. 4 times 7 is 28. So let's go down here and say for 3, 28 somewhere, okay? I see 3 28s down here at the very end. And that means I'd put letter T down there for that one. All right, it looks like I got time to do one more question. I'll do one here with the marbles, okay? So I'll do letter R right here about green and then not green. And I'll get a little bit closer on this one. Find that out some. All right, so we're going to do letter R right here. Green, then not green. So if you look at all these marbles, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 marbles in there. How many of them are green? 1, 2, 3, 4. So your theoretical probability of pulling the green one is 4/9. Don't really have a lot of room to write this in here. 4/9. I'll have to write it as a slash. All right. So then you pretend you pull out a green one. That's what without replacing the first means. So I'm going to pretend I stuck my hand in there and I pulled out a green one. So I'm just going to cover that one up with I'll cover it up with my pen right there. That'll be easier. So that green one right there is no longer in the mix. All right. Then what's the probability of getting not green? Well, not green would be those 2 red ones and those 3 yellow ones. So that's 1, 2, 3, 4, 5 out of 5, 6, 7, 8. So 5 out of 8. So probability of not green is 5 out of 8 because I pulled that one out. Okay. Again, 5 out of 8. All right. So 4/9, pulled one out, and then that means there were 8 left in there. Now again, I can cross reduce these, the 4 and the 8. Okay. 4 goes into 4 one time. 4 goes into 8 twice. So I got 1 times 5 is 5. 9 times 2 is 18. So the theoretical probability of pulling the green marble out and then pulling a not green marble out is 5 out of 18. Y'all see 5/18 right there? We're going to put your letter R right there where 5/18 is. Okay? So, in summary, okay, independent means that they are happening separately, okay, and you just multiply the 2 probabilities together, okay. Dependent means that the second event is affected by the first event, okay, because one event is affected by the other, and the keywords you're going to see there are do not replace, or also without replacing, which means the same thing, without replacing. And you can just cover it up with your finger, or you can cover it up with your pencil or pen or whatever on that particular question. And then when you get done with the question, all of them go back in the bag, okay? So, hope that gives you a good explanation. Hope you're down like that, all right? If you know the name of this song, feel free to send it to me. And that is all for independent versus dependent today. Hope you're feeling all right, and we'll check you next time. Sweet ciao!